This is the Smart Buildings Academy podcast with Michael Roper here, and this is episode number 515. So, welcome to the Smart Buildings Academy podcast. Today's episode will be about designing BACnet over IP networks. Now, all information that's covered in this episode can be found on our website at podcast.smartbuildingsacademy.com/515. Okay, so now that we got the intro out of the way, let's go ahead and get into the podcast agenda and some of the topics we'll be going over. So we're going to start off going over the importance of BACnet over IP network design. This is before we install anything physically on the job site. This is laying out the foundation, designing the system with two goals in mind. We want it to be a stable system, and we want it to also be scalable for our BAS systems too as well. So we can add on to that without any issues. Next, we're going to get into some core networking concepts that apply to BACnet over IP. So we'll talk about some IP addressing, subnets, maybe some VLANs, and also some IT alignment with our customers for our BAS systems. Then we'll get into addressing and then segmentation and how that's important. Devices and controllers, where we go over some understanding the limits, like how many devices we can put on a BACnet over IP link or network. And then we'll go over some roles and also some configurations with those controllers as well. And then we'll get into the routing and BBMDs. So that just kind of goes over enabling communication across multiple subnetworks through the BBMD. And then we'll get into some performance and reliability. We're going to talk about how we can avoid congestion and planning for resiliency, making your network strong so we don't have any issues with it. And then we'll go over some best practices whenever you're dealing with BACnet over IP installations, standardizing some different processes, maybe documenting for long-term success, and helping the service department if they ever have to troubleshoot behind the initial startup. Okay, and then we'll kind of summarize at the end, recapping what we went over. Okay, so let's go ahead and get started on the first topic. The first topic we have today is why BACnet over IP network design matters. Okay, why it's important to lay out these networks before we physically install it. Okay, now many of you might have seen these already out in the field, but a poor design, as you know, leads to bad performance. Okay, so it can slow down your graphics. It can slow down your data processing. If you're running a trend, might even slow down your communication between controllers. Could cause delayed alarms, and devices can also drop offline too as well in their communication. So performance and uptime impact is very important in that aspect. Now, BACnet over IP relies on the IT backbone, our customer's backbone. So issues that might be on our BAS can affect corporate networks. All right. So maybe our system might be bogging down our customer network. So we got to be aware of that. A poor design could lead to that. Vice versa, it could go the other way around too, if you think about it. So a customer's network, if it's poorly designed, it could affect our network, our BAS network, and how we communicate and pass data from controller to controller on their network. So IT teams often run into problems with BAS systems when broadcasts aren't managed properly. Okay, so maybe they're not have an issue with how it's managed there. So strong designs usually ensure good performance in the present time, and it's easier to maintain in the future. All right, so not only it helps up front, but it also helps in the future if you ever want to add on to that system for scalability. Okay. Also, troubleshooting is another advantage of a good plan too as well. If you document everything and how everything was installed and designed, that's going to be very valuable for anybody that has to service that system or troubleshoot that system in the future behind them. So that's another good aspect of that, of a good network design up front. Just making sure that we're aware of these different types of things. Another thing we got to be aware of too, that could cause, and we'll talk about this a little bit more later in the podcast, is, if you have too many devices on a link, or if you have too many devices on the controller, sometimes, I guess I was thinking of MSTP because that's what I'm used to, but I've been really transitioning and learning more about BACnet over IP. The more I learn about it, the more I like it. But they don't have links; they have Ethernet ports. So you are restricted to device number limitations on those as well. Okay, now let's talk about some of the core concepts for building automation systems when we talk about BACnet over IP. So we're going to get to the basics. Every BACnet over IP controller needs an IP address. Okay, that IP address has to be unique on that sub network. Of course, as we know that for basic BACnet over IP knowledge, there it has to have a subnet mask, and it also has to have a gateway. Now the gateway is important. If we're not going outside a subnetwork, we usually don't need that gateway. But anytime we set up two subnetworks, we're going to have a gateway to be able to know where to go to and from to another subnet. Now, subnets also define communication boundaries, and they also limit broadcast traffic too as well. So that can help as well on those two situations whenever you're designing your network. Now, sometimes we might see VLANs or virtual local area networks, and sometimes those are used to separate BAS traffic from corporate or guest networks. All right. Now, this is not only important to help the speed of the network, but also it helps increase the security. Because as we know, your customers might not want the BAS system on the same network as their accounting system, or on the same system as their human resources, where they have all personal information of their employees, and also maybe sensitive data that they don't want the public to see. All right. So VLANs are important to use, and that's a kind of a core networking concept. Maybe you're using them out in the field, but that is one thing we could do too as well to help out with that. Switches, when we talk about switches, switches connect to local devices, and they're just kind of really just like a pass through from one device to the next device. Now, routers are different than switches. Sometimes people think routers are switches and switches are routers, but they're not. They're different, unless you get like a layer 3 switch or something like that. But the routers move between sub-networks. Switches cannot do that, but routers do go between networks. And then firewalls are very important too when we're talking with our customers and setting up their system to make sure they protect their systems, all right? Make sure that our controllers are behind their firewall to make sure no hackers can get into the system through the BAS. Now, BAS traffic doesn't use heavy bandwidth, but it does require low latency and also reliability too as well. So BAS bandwidth really isn't that heavy most of the time when you compare it to some of the other business systems that are going on frequently throughout the building. But timing's critical on that. So we need to be aware of that too as we're laying out our networks and understanding the networking concepts for BAS. Okay, so that kind of wraps up this segment. That's all I really want to talk about, core networking concepts, just the different types of like VLANs and subnets when we're going to use those, the different devices you'll see in between there. IPv4 is the most commonly used, I think, right now, but I think a lot of companies are going to IPv6 because that's where the future's going as far as IP or standardization is going. Okay, so that kind of wraps up that segment. We'll go ahead and move on to our next section here. Our next segment, we're going to be talking about something that's really important, and this could be a spot where we can learn about troubleshooting and making sure everything's set up correctly. This is where we're going to talk about the BACnet over IP addressing and also segmentation if we need to segmentate certain parts of the network out. So basically, BACnet device instances must be unique, just like IP addresses. So a BACnet device has an instance. Every BACnet device has that. That's what makes it a unique device on your network. All right. So that's kind of a comparison between those two. A BACnet device uses logical IDs, and they must be unique, and an IP address is like an IPv4 address. That also must be unique on the subnetwork, whatever subnet you're using. Now, segments can divide traffic into manageable groups for performance. So segments are logical divisions that control broadcast domains from our BACnet data. So that's one way we could do that with address segmentation. Now, BACnet uses broadcast also, as we know, for discovery. Also broadcast to see if there's any alarms out there. Maybe it's broadcasting from device to device to share global points with each other. You know, a lot of times we're going to be sharing outside air temperature sensor. I mean, you might have a building where they have to have a subnetwork for maybe accounting, and they want to have, you know, or maybe it's a tenant per floor, a different subnet per floor. But we want to use the same outside air temperature sensor that could be a global point that we could share between all the controllers on the on the network. So each subnet on the network, we can share the outside air temp. We could share a global outside air humidity temperature too as well. Okay, we might be able to share building power consumption. Okay, total building power consumption. All right. So those are some things we could do when we talk about segmenting the traffic there. Segmentation becomes necessary with high device counts, performance issues, or IT managed subnetting. Okay. So if you think about it, we might have to, once we exceed our limitation on our supervisor controller, whatever supervisor controller you might be using, you might have to segment that out and put them on different subnetworks to satisfy that requirement as far as that goes. Okay, it could be a performance issue. Okay, it could be, you know, your network could be slowing down, and so that could be a indication that we need to start segmenting and dividing out this network so we don't just consume everything on one network and take over all that bandwidth. Okay, so I think that's all I want to talk about on part 3 over there on addressing and segmentation. Let's go ahead and get into devices and controllers. So we're going to focus specifically on IP controllers, BAS-IP controllers. Now, and today, we could also put devices and sensors in this topic too as well, because as we see now, we're seeing relays that have IP capability on it. Okay, also just, you know, zone sensors and anything else that you could think of is going towards IP addressing. Now, supervisors are probably going to be the most common piece that we're going to see that will be like an IP controller. You know, back in my day when I started over 20 years ago in this industry, that's all we had to worry about was putting an IP address on the supervisor. All right. We didn't have an IP address for every single controller on the network. That technology, I mean, it was probably there, but it wasn't popular yet at the time. So we would just get an IP address from the IT department. Just for the supervisor, we might have a web server too to connect to it, and then we would be done with that. I mean, that's all there is. So supervisor controllers coordinate all the system level operations, and then field controllers handle the inputs and outputs, of course, as we know. Now today, we have field controllers that can handle IP. Okay, so we got to put those and give those IP addresses to put them on the network. Now, practical limits for devices per subnet. Okay. Now, usually the rule of thumb, maybe 50 to 100 devices, depending on how much data you're broadcasting across the network. You know, usually the manufacturer will have that in their data sheet. So whatever vendor you're using, whatever controls manufacturer you're repping, always make sure you look at the limitation, the device limitation, how many you can put on the supervisor. Even though the standard might allow more, you might want to stay, you know, as a rule of thumb, 50 to 100 if you can. All right. And also that can also help if you're allowed to have more, you know, you might want to go ahead and put another supervisor in there and allow for scalability in the future. So you can only, if you can have 150 on that controller, you have enough room to put some more in case they have a remodel or an addition or something like that. So you have some room for expansion. A lot of times, if you read the spec, they require like 20% or 30% more points for expansion, or controllers for expansion anyways. Okay. So those are, even though the standard might allow more, the BACnet-IP per device, make sure you pay attention to the manufacturer's recommendations and their requirements, because those could be quite different than what this rule of thumb looks like. Okay. Now, one thing that can be kind of tricky is the type of IP address that we're using in the controller. So they could be DHCP, which is our dynamic host communication protocol. And that's where they're basically going to get the IP address. It's going to be issued to the controller from the DHCP server. All right. Now, these IP addresses are leased, which means they're not permanent, as we all know. So whenever the device is connected for the first time, whenever you connect that Ethernet cable to the Ethernet port, it's going to go make a request to that DHCP server, and then that DHCP server is going to issue an address that can be changeable in the future. If they ever disconnect or power resets on that controller, it'll send another request to the DHCP server. Okay. Now, as we know, some of you are already thinking this in your head. Well, that's going to cause problems, because in my supervisor controller or my field controller, I went ahead and entered a static IP address. I typed in an IP address, and it's, once you type in a static IP address, which is probably the most popular way to set these up, it's going to stay there forever. Okay, that's the best way to do it when we're putting our devices on the network, is going with static if we can. Now, there is some capabilities, depending on if you're using like a VPN software from your manufacturer, and maybe they allow that to go through DHCP. There's ways to do that, but sometimes you might have to coordinate with your IT department to get like a sticky IP address, and what that would do, or IP sticky. I get those two terms reversed. Phil Zito had to correct me on that. I always say sticky IP, but I think it's called IP sticky technically. But anyways, that will just basically, it's kind of like a static IP. And whenever it is reserved, when the first time you connect to the network, it'll assign an IP address. And once it does that, it stays there like a static IP. It'll never change after that. Even if you unplug it, it'll still stay on that IP address. Okay, so there's some workarounds you could do with DHCP, but it's best practice just to request a static IP if you can. When you're talking to your IT professionals to get it on the network, make sure you did your homework, make sure you have your MAC addresses on all your controllers, and then they'll assign the IP address to the MAC address. Okay. If you ever want to find out your MAC addresses, you can always go to the command prompt and type ARP-A. Okay. Yeah, so that pretty much covers DHCP with static. So just be aware of that. Another thing that we like to have on our devices and controllers is redundancy. It's important. I mean, think about your critical equipment like your chill water plant in a hospital. Okay, maybe it's something else, some kind of critical facility where they're manufacturing sensitive parts. Okay, and you got to have it within a certain tolerance. So backup controllers or redundant paths are very important. That's always good to have a backup in case one port fails on either one of your supervisors. You can always it's always good to have a backup just in case, like a fallback port. Make sure you have that at least set up. If your controller goes out, I don't know, you just got to have a plan ready with your customer what to do if this happens. You might even have an additional controller on site for that chill water plant, or whatever type of critical system they're trying to control. Okay, have that ready to go, and you can just plug and play and replace it and get them up and going quickly. Okay. Don't take the risk these days in case the part might take a few days to get in, maybe weeks, with our crazy shipping things and how that goes these days. Okay, so next topic we're going to talk about is the routing, the BBMDs, and also the subnets. So BACnet routers connect MSTP devices to IP or link different IP networks. Okay, you can go from MSTP to IP, kind of like what I used to do 20 years ago. We would have an MSTP trunk to the supervisor, and then you could convert at the supervisor IP, and then you can connect to IP. Then you could see the MSTP trunk from there. Or you could just go IP to IP, which is what we normally do today. And what's becoming more popular out there is just going straight IP. Okay. Now, BBMDs, BACnet broadcast management devices. Okay. So that handles traffic across subnets so they can discover each other. So if you have two supervisors on two different subnets, both of them have to be set up as a BBMD because we're going to need to be broadcasting information to each other so they can share it and see each other across two subnetworks. Okay, so they're going to have a BBMD table in each controller and also a BDT table, BACnet distribution table, to forward the broadcast messages correctly. So if you have a BBMD and a SC plus on one side, it's got to know the IP address and how to get to, and the gateway, how to get out of the subnet and go to the other one in order to talk to it, okay, to receive information and pass points if it needs to pass points, share a schedule, alarms, trends, things like that. Okay, so you're going to have the BBMD enabled on both controllers and the BDT of both IP addresses across each other. Okay, they need to know which IP address and gateway to go to. Now, in large buildings, or large campuses, not buildings, maybe like a campus, because usually we're going to put a supervisor per building is how it usually goes. So each building might be its own subnet. So per supervisor controller, that might be one subnet for one building, but they might be tied all together with BBMDs acting as one. So that's one thing to keep in mind if you're working with large campuses. Maybe it's a university or a hospital or something like that, school. You can set it up like that. Okay. So let's go ahead and go over performance and reliability. Now this is a big issue too, because not only can this affect our BAS network, which we're responsible for, and we can fix it, but one thing we don't want it to do is interfere with our customer network too as well. So we don't want that to drag over into the customer network and start messing with the performance of their network. So we talked about this already, and we need to be aware of this, and it's probably worth repeating again. Too many devices on a subnet can create broadcast storms. Okay, if you get too many devices and they're trying to spit out so much information to each other, that can slow down the network, and that's a broadcast storm. That's a lot of information going over the network. Overloaded controllers may drop packets, okay, causing nuisance and offline alarms. All right, so if you have a lot of field controllers and they're passing a lot of information, they could drop packets on that. Resilience or redundancy comes from like a UPS, like a backup system, and then also redundant network hardware, failover planning, like we talked about before. If one port fails, what's our fallback port going to be? Okay. Just hopefully the controller didn't go down, but maybe just a port's messed up, so it can fall back if communication fails there. Also, you can also measure performance and reliability by kind of using monitoring tools. Okay, network monitoring tools, such as Wireshark, that helps confirm traffic flow and also diagnose issues. There's also like Serial Spy. There's a lot of different BACnet type software that you can look at, and it'll just tell you if your data is going from point A to point B, when it's acknowledged, when it's requested, how many packets made it from point A to point B, and so on. Okay. All right, that pretty much wraps up performance and reliability. We've been talking about a lot of that already. The only thing that's really new, kind of like some of the monitoring tools and things like that. The last, actually, we got two more topics we're gonna get into today. The the seventh topic we're going to get into is some common mistakes in troubleshooting that you can do. And we talked about this a lot already. So one of the common mistakes is overloading a subnet. Okay, remember, stay between 50 to 100 devices. Also refer to your vendor or your manufacturer's data sheet to see what the limitations are per network. Okay, until it starts becoming having issues. Misconfigured BBMDs can create mysterious communication gaps. I've seen this before. If you enter the wrong IP address going from one supervisor to another across the subnetwork, it's not going to get there. Also, make sure not only the IP address, the gateway has to be set up too to get across the subnetwork. Make sure you're also on the right subnet mask. Okay, so that's going to affect what subnetwork you're even on. Okay, so make sure the subnetworks match up too as well. Another thing we talked about is DHCP and static IP addressing without coordination can cause some issues. Now, like I said before, DHCP is fine to use if your software will allow you to do that. But you might have to coordinate with the IT department if you want to make it an IP sticky address or something like that. But static IP addressing is the way to go. It's the fastest way to do it. Well, maybe not the fastest because you have to go coordinate with the IT department to request, your host IDs, however many IP addresses you need. But once you get that, it's probably, I should say, it's the most reliable way to do it because it will not forget that static address. It stays in there permanently. We don't have to worry about it unless that controller goes down. Another common mistake, and this can also help with troubleshooting, as we know, is the lack of documentation. Okay. Now, at least make sure we have a right system architecture. What kind did we use? Like a daisy chain per floor? Did we do a home run for all controllers all the way back in a star formation, back to a switch or back to the router? So these are things that need to be put in the job folder or scanned and put on your network. If you store your job folders electronically, make sure we put that in there, and your service department, whoever has to go out there and troubleshoot these things, knows where that information is so they can look through it if they need to. Because not all times the IT department at your customer's job site, they might not know all these details when the BAS tech was out there to fix it. They just know that they fixed it and they went home after they did. So documenting is very important. The steps that you took to figure out the problems. Okay, some common problems that are at that job site. That's another good thing to document. And then just some the basic, how many devices are on the network and things like that. Okay. All right, I think we're done with that topic and we can move on to our last one. Then we'll wrap up for the day because we are almost out of time here. So let's talk about best design practices and also design workflow. All right, so we need to standardize IP addressing schemes by building. Okay, could be, if you have a campus, you could be separating it out by buildings per subnet. You could do it by floor. That's very popular if your customer has tenants. Okay, if it's like a property manager, he's renting out his different floors per tenant. Okay, so you might want to do a subnet per floor, or maybe even a system type. I don't know. Maybe you want to put all the VAVs on one. I don't think I've ever done anything like that, but that could be an option. Something to do on that. Thoroughly document the network design, like we said before. Include tables. Okay, include the MAC addresses of all your controllers, and the IP address of all your controllers. Okay, this could help if a controller ever goes offline. You need to go look at it, see what it is, what MAC address it is, and then if you have that table, you could just reuse the existing IP address when you go talk to the IT professional at your customer's job site. Okay. Involve IT early to align BAS with enterprise standards. If they have any kind of standards, like if they can't use HTTP, you got to use HTTPS. If you got to use TLS, over SSL, little things like that. Just get there early. Okay. Usually we're going to be at the very end when we do our comm anyways. So maybe when you're doing your job walk, your initial job walk on the job site before startup, that might be a good time to get the IT department involved in a short meeting, just to kind of give them some information about your controller, the security standards. That way they feel more comfortable putting that on their network. And then also if there's anything you need to know beforehand, just whenever you're setting up that that network. Validate designs in a lab or pilot setup before deployment. So if you can do a bench test, if you have some stuff in your office, get a table out, just try to test that out on the table before you get out to the job site. Just basic stuff right there. Just do a little pilot, use the actual IP addresses and all that. And if you have a router at the office, you can simulate that. Okay, so that might be something you could do too. That will just eliminate any kind of issues you get out when you get out on the job site. Okay, well that pretty much wraps up, our podcast here. So we just kind of went over the BACnet over IP design. It directly impacts performance, reliability, and maintainability. So make sure we stay within those device limitations. And network fundamentals and BACnet specific concepts must be understood. So make sure when you're setting this up, you're working with your team and everybody understands, what a host ID is, what a network ID is, what routers are for, what switches are for. Make sure your subcontractors know that too. Hopefully they know that, and make sure everybody understands that. Proper addressing. Remember that we need to make sure and keep track of our addresses on our supervisor controllers and our gateways. That way we know what to use when we're setting up our BBMDs and our BDT tables. And also planning and documentation. Don't forget to do that so that can help the people behind you after you do your startup. They can come back behind you and understand how to troubleshoot that system or even service it if they need to. All right. Well, thank you very much for listening to the Smart Buildings Academy podcast. We hope you learned a lot from this episode. If you found this episode valuable, please leave us a 5-star review on Apple Podcast or Spotify. If you're watching this on YouTube, please like, comment, and subscribe. As always, this will be available on our website at podcast.smartbuildingsacademy.com/515. Thank you very much, and we'll see you all next week. Take care and have a good one.